fx equals 20 over x plus x, where x does not equal to 0. This means that for the function, there is no value at x equals 0, and we do not draw a graph there. A. Complete the table. The table is missing two values for 5 and 8. For 5, we just need to substitute 5 into the function f, which is equal to 20 divided by 5 plus 5, which equals 9. For 8, we need to substitute 8 into the function f. That's 20 divided by 8 plus 8, which equals 10.5. B. On the grid, draw the graph of y equals fx for x minus 10 to minus 1.6 and x from 1.6 to 10. All we need to do is plot these points, the x's on the x-axis and the f values or the function values on the y-axis. Once we plot the coordinates, we need to join them with a smooth curve. Because these coordinates come from a function, you can expect it to be a smooth graph, but then if you plot it and it's something like this, you can expect the abnormal point to be wrong, and therefore you would need to check your answer for this coordinate. Because there's no value for this function at x equal to 0 or x does not equal to 0, there's no value around this point. So we can't just join these two points. They are two separate areas from the same function. C. Using your graph, solve the equation fx equals 11. So that's when the value of the function equals 11. We want to know when the function f equals 11. The function f is defined by 20 over x plus x, and we want to know what x value makes this equal to 11. So we can use our graph to solve this. When we want to solve something using a graph, we need to draw lines for this side of the equation and lines for this side of the equation. So for the left-hand side, we need to draw the line y equals 20 over x plus x, which we already drew right here. And for the right-hand side, we need to draw the line y equals 11. And the solution to this would be where these two graphs intersect. So all we need to do is draw the line y equals 11 because we already drew the other line. The x coordinates of where those two lines intersect will be the solution to the equation. So that's here and here. So one of the solutions is here and the other one is here. This one approximately is around 2.6 and this one is approximately 8.8. So these are our two answers. So for C, we have x equals 2.6 and x equals 8.8. Because we were solving for fx equals 11, this means that the answers that we got when substituted into the function f should give approximately 11. This means that f of 2.6 and f of 8.8 should approximately give 11. Using a calculator, we can quickly check our answer. Does these substitutions equal 11 or something close to 11? It's important to remember that when you get your answers from a graph, it's an approximate answer because of the curve that you drew. It might not be 100% accurate, so getting a value that's close to 11 or plus and minus 1 from 11 is acceptable. B. K is a prime number and fx equals k has no solutions. find the possible values of k. Finding the solutions to fx equals k is similar to part C. When we want to find these solutions, we're looking for the intersection between the line y equals fx, which we already drew, and the line y equals k, where k is a prime number. So k could be the line y equals 2, y equals 3, y equals 5, y equals 7, y equals 11, and so on for prime numbers. From part C, we know that the line y equals 11 has two solutions, 2.6 and 8.6. But this time, we're looking for a line y equals a number that doesn't have any solutions. If it doesn't have any solutions, it means that the lines do not intersect. So for all the lines y equals prime numbers that we just drew, there are only 4 that do not intersect the black line or the curve, and those are y equals 7, y equals 5, y equals 3, and y equals 2, because y equals 11 crosses the curve 2 points, y equals 13 should also cross the curve at 2 points, and of course y equals 17 should also cross the curve at 2 points. Negative numbers are not prime numbers because they have at least 4 factors. For example, minus 2 could be made from minus 2 multiplied by 1 and 2 multiplied by minus 1. So no negative numbers are prime numbers. So for C, our answers are y equals 2, y equals 3, y equals 5, and y equals 11. So K could be 2, 3, 5, and 7. The gradient of the graph y equals fx at the point 2, 12 is minus 4. Write down the coordinates of the other point on the graph of y equals fx where the gradient is minus 4. So the gradient at the coordinates 2, 12, which is this point, is minus 4. If you look at the graph carefully, you can see that the graph on this side of the equation is also the same as the graph on this side. So you can suspect that if this coordinate over here has a gradient of minus 4, the one that's opposite and the same to it should also have a gradient of minus 4, which should be this point, or the coordinate minus 2, minus 12. And if you try and rotate the graph 180 degrees, we can see that it looks exactly the same. This means that if the coordinates 2, minus 12 have a gradient of minus 4, then the coordinates minus 2, minus 12 should also have the same gradient. Therefore, our answer is the coordinates minus 2, minus 12. The equation fx equals x squared can be written as x cubed plus x squared plus q equals 0. Show that p equals minus 1 and q equals minus 20. We want to start with the equation fx equals x squared. In this case, our fx is equal to 20 over x plus x, and that should equal x squared. Then we want to manipulate this expression and rewrite it so that it looks like this expression. If you look at the expression that we want, none of them is a fraction, or none of them have denominators. So the first step, let's get rid of the denominator. We can get rid of the denominator by multiplying both sides by the denominator. So we can do multiplied by x to both sides. When you multiply 20 over x by x, the x cancels out, leaving 20. And when you multiply x by x, you get x squared. And on the other side of the equation, x squared multiplied by x is x cubed. Now, we have similar terms to the expression we want. We have an x cubed, we have an x squared, and we have a number term. All we need to do is move everything to one side. We can remove x cubed from the right-hand side by doing minus x cubed, so that x cubed minus x cubed is equal to 0, but we have to do it to the other side as well, so that's minus x cubed here, and plus the rest of the expression. On the left-hand side, we will have minus x cubed plus 20 plus x squared equals 0. And now, we can multiply both sides by minus 1 so that it's a plus x cubed here and a plus x cubed in our expression. So when we multiply everything by minus 1, minus x cubed turns into positive x cubed, like in the expression that we want. Then we have minus x squared and minus 20, and that equals 0. So by direct comparison, the coefficient of x squared should be equal to p, or the number in front. In this case, the number in front of the x squared is minus 1. And q is just the number behind it, or the number without an x term, which is this. So q equals minus 20. And that's exactly what the question wanted us to do. Show that p equals minus 1 and show that q equals minus 20. Part 2. On the grid opposite, draw the graph of y equals x squared for x from minus 4 to 4. So to draw the graph of y equals x squared, we just need to substitute some x coordinates into the equation. So if x equals 1, y equals 1 squared, which is 1. If x equals 2, y equals 2 squared, which is 4. If x equals 4, y equals 4 squared, which is 16. If you do the same for x coordinates from minus 4 to 4, we can plot these coordinates and then we need to join them with a smooth curve. After joining the coordinates, you should have a smooth curve like this. Again, if there's an anomaly in the coordinates, it should be wrong because we're plotting these from a function. It should be one smooth curve. Part 3. Using your graphs, solve the equation x cubed minus x squared minus 20 equals 0. If you notice, this expression is the expression that we simplified or rearranged from this expression in part 1. We managed to rearrange it into this or into this. Therefore, solving x cubed minus x squared minus 20 is the same as solving this equation, or solving where does the graph of fx cross the graph of x squared. And we can do this, or we can find this from the graph that we just drew. We already drew the graph of y equals x squared in the previous part of the question, and we've drawn the graph of y equals fx already here. So solving fx equals x squared is like finding the points of intersection between these two graphs, and that is this point, and this point corresponds to the x coordinate, and that x coordinate corresponds to approximately 3.1. So our solution is x equals 3.1. Don't worry if you don't get the exact same answer as me, because this is using your graph. You should put the answer in according to your graph. The answer will depend on the accuracy of your graph. So the answer will be plus or minus 1 from the actual value. However, we have a way to check the accuracy of your answer. If x equals 3.1 for this expression. This means that this value of x cubed, then minus the square, then minus 20 should equal 0. So if you substitute this value of x into the expression, we can do 3.1 to the power of 3 minus 3.1 to the power of 2 minus 20. We should get something close to 0, and we can use our calculator to help us. When substituting 3.1 into the expression, it equals 0.181, which is very, very close to 0, and therefore our answer is correct. Part 4. The diagram shows a sketch of the graph y equals x cubed minus x squared minus 20. P is the point n0. Write down the value of n. If you are confused with this question, notice that this question is only 1 mark. This means you should be able to get the answer from somewhere. The point P is this point on the sketch. The y-coordinate of the point P is 0. This means the n that we're looking for is the x-intercept of the graph. And whenever we want to find the x-intercept of any graph, we substitute y equals 0 because it's when the y-coordinate is equal to 0. So if I substitute this y with 0, the expression turns into 0 equals x cubed minus x squared minus 20, which is the exact expression we used our graph to solve in the previous part. So the n is equal to x from our previous part, which is equal to 3.1. Therefore, n equals 3.1.